Good morning, guys. So the next thing that we are going to be talking about is kind of applying trig to more so the concepts that you might see moving forward in math, but also concepts you might also see on the SAT. And to be able to do that, we have to take a step back and actually review something from back in geometry. So we need to review our special right triangles. So for the 45, 45, 90 triangle, label each side length as 1. So this will be a length of 1, this will be a length of 1. Okay, what would the hypotenuse be using the patterns you learned in geometry? And I'm going to leave that blank because I want you to try to see what you remember, okay? For the 30, 60, 90 triangle, label the shorter of the two sides 1. What would the hypotenuse and the long leg be using the patterns you learned in geometry? Go ahead and pause the video, try to see it, or at least make a guess, see what you remember from geometry last year, and see if you remember the patterns. When you're ready to see the answers, go ahead and unpause, and I'll let you know. All right, so for the 45, 45, 90, if both side lengths are 1, then this pattern is 1 root 2. Now, I know technically I don't need the 1 in front. The reason I did that initially is so you could see you just basically tack on whatever the side length is, tack on a root 2. So I am going to erase it now, but I just want to make sure you knew that, okay? All right, when you've got the 30, 60, 90, the short leg goes with the 30-degree angle if you can't tell for sure. But usually it's drawn pretty accurately so you can kind of tell. The hypotenuse is always double whatever that side length is. So if this side length is 1, the hypotenuse is 2. And then the long leg is whatever the short leg is, and you tack on root 3. Again, I wrote the 1 in the front just so that you see how you're kind of adding on the square root of 3, but we don't actually need it, so I'm going to erase it and just kind of go from there. So those are the patterns. So depending on what the side lengths are, things like that, you have to be able to go back and forth. So let's do a couple practice problems just to kind of review this concept from geometry. All right, find the two missing sides in each of the triangles without a calculator and no trig is allowed. So the reason, like, I know you guys can set up sine, cosine, tangent. We've been practicing that. But I want you to practice the special right triangles because the next thing we move into is going to take special right triangles and these 6 trig functions, these 6 trig ratios, and kind of morph them together so you can see where we're going with this. So if you want to, go ahead and try these questions, and then when you're ready, or if you are getting stuck, you can unpause the video to see how you're doing. All right, so for letter A, it's a 45, 45, 90, and the side length there is 7. So because it's a 45, 45, 90, if this side length is 7, this side length is also 7. And according to our pattern, whatever those side lengths are, the hypotenuse, you just tack on a square root of 2. Okay, so in this case, y is 7 and x is 7 root 2. All right, let's take a look at letter B. This one's a little bit trickier because we're given the hypotenuse instead. Okay, we don't actually know what x is. So if in letter A, for example, we had 7 and we multiplied by root 2, if I have this 8 right here, I want to figure out 8 divided by square root of 2. Now, here's the thing. This is a little trick to this. This is a very weird thing to see in math. 8 divided by square root of 2. It's kind of like seeing a decimal inside of a fraction. Like if you saw 3.5 over 6, that's really weird, right? We would turn 3.5 into a fraction and we'd simplify it and all that fun stuff. The other thing is we could make 8 divided by square root of 2 a decimal, but it says without a calculator, and it says leave your answer in simplest radical form. So what we're going to do is a little trick to kind of rewrite it so that we do not have a square root of 2 on the bottom. So here's how we do that. You multiply by square root of 2 over square root of 2. The reason for that is 5 divided by 5 is 1. 10 divided by 10 is 1. Square root of 2 divided by square root of 2 is 1. So really, if I'm multiplying my answer by 1, I'm not changing it. Then what happens is when you multiply straight across, you get 8 square root of 2 on the top, and square root of 2 times square root of 2 is just 2. So here's the other weird part. Even though we can't have a square root of 2 on the bottom, it's okay to have it on the top. Basically what this is called, it's kind of called rationalizing the denominator. It's kind of a weird thing that comes up with these trig functions that you need to be able to do. then kind of thinking back to quadratic formula from back in the day, you can simplify the 8 and the 2 in the front and just make that 4 root 2 by dividing. So x in this case for both sides is 4 root 2. If you don't believe me, or if you want to check your answer, you can always take that, and if you do 4 root 2 and you multiply by root 2 using our pattern, you get 4 times 2, which gets you back to 8 for the hypotenuse. So if you weren't quite sure about that. All right, let's take a look at these other questions. These ones are working with the 30, 60, 90. I'm actually going to go to a different slide so I have a little bit more room to work. All right, so the pattern is if you have the short side, so like in this case, x is the short side because it's directly across from the 30-degree angle. It also looks like the short side. Whatever that number is, you double it to get the hypotenuse. So if the hypotenuse is 18, this x value must be 9. Then the long side is whatever the short side is, and then you multiply by root 3. So this should be 9 root 3 right here. So my recommendation, if you don't have the short side, that's usually the first thing you want to solve when you're looking at a 30, 60, 90, okay? If I look at letter D, I do have the short side, yay. So the longer side is just 6 root 3. And then the hypotenuse, you're doubling it. So double 6 is 12. So x is equal to 12, y is equal to 6 root 3. So far, not too bad. Now, letter E, this is where things get a little bit tricky, just like it did for that second one for the 45, 45, 90s. So normally, it's whatever the short side is, you multiply by square root of 3 to get 9. So if that's the case, I need to take 9 and divide by square root of 3. Okay, here's what I'd like you to do. I want you to pause the video and practice rationalizing the denominator. Think about what you would multiply this by to make this expression look nicer without using a calculator, okay, and leaving it in radical format. And then when you're ready, unpause it, and let's see if you get the right answer. All right, if I multiply something by 1, it doesn't change it. So I'm going to multiply by square root of 3 over square root of 3 to rationalize the denominator. Because on the top, I'll get 9 root 3, and on the bottom, square root of 3 times square root of 3 is just 3. I can also then reduce this 9 divided by 3, and so I actually get that C is 3 root 3 in this case. Okay, whatever the short side is, you're doubling it to get the hypotenuse. So if I have 3 root 3 and I multiply that by 2, that's going to, oh gosh, that was a weird number. That's going to turn into 6 root 3 when I go to double that, okay? So that's our lesson for today, kind of quick. If you need extra practice, you can like look some things up online. There's tons of videos out there to kind of help you out. You are going to have an assignment tomorrow that you're going to be working on that's going to be all about practicing with these special right triangles, kind of reviewing some of that concept from geometry. So as always, if you're getting stuck or if you have questions, if you want to just say hi, stop in for my office hours so that I can help. All right, good luck, guys.